Good morning, good afternoon, good evening. Welcome to today's webinar, Modeling and Querying Data and Relationships in Salesforce. I'm Chris Chant and I'll be your host. Today we are joined by Peter Chittum from the Developer Evangelism team here at Salesforce. He'll be speaking about the Salesforce data model, the SOQL query language, and modeling and querying that data in Salesforce. Before I begin, just a quick note, we have our infamous safe harbor slide. When considering future developments, whether by us or with any other solution provider, you should always base your purchasing decisions on products and features that are currently available by Salesforce. Just a key takeaway for this slide, we are a publicly traded company. Please make any buying decisions only on the products commercially available from Salesforce. Also, please sure to check us out on all your favorite social channels. We are Salesforce developers on Twitter, Facebook, LinkedIn, and YouTube. And with that, we are ready to get started with today's session, Modeling and Querying Data and Relationship in Salesforce. You want to take it away, Peter?
Great. Thanks a lot, Chris. And thank you, everyone, for coming to this webinar today. As Chris said, my name is Peter Chittum. I'm a developer evangelist, and I also manage the developer evangelist team in the EMEA region. This particular webinar came about as kind of a discussion that we were having as I was going to post the blog article that you see here. So what I'm going to talk about today is very similar to what I talk about in that particular blog post. However, the blog post actually goes into a little bit more detail about certain things like Salesforce multi-tenancy. So I really see these two things as going together. So after you've checked out the webinar, make sure to go out and check out the blog post after that. And you'll get even more for your money. So with that, let's take a look at the agenda. I'm going to break this webinar into two larger parts. The first part, I'm going to talk kind of generally about data model and relationships in Salesforce. And specifically, I want to make some comparisons between relational databases and Force.com data model and what that looks like. I also want to talk specifically about relationships and relationship types and kind of what those mean. And in the second part, I'm going to jump in and talk about how relationships work with the SOQL query language. So there we go. That's kind of it. And a big part of the discussion on the SOQL query language and relationships is the relationship query and what that looks like, because that's a fundamentally different thing than if you've used SQL before. Now, I've made some assumptions as far as who I built this content for, both the blog post and the webinar today. The first is that I'm kind of looking at an audience that is new but has a basic understanding of the Force.com platform. So, I'm expecting you've maybe created some custom objects and fields. You're somewhat familiar with navigating or basic navigation of the user interface. I'm also looking specifically at an audience of people who are familiar with relational database concepts. So somebody who has worked with or created tables, joins, primary keys, foreign keys, indexes, that sort of thing. I'm going to talk about some of these things, and I'm not going to explain them as I go through. So I'm kind of assuming that you have at least some basic literacy in SQL and relational databases. And with that, let's jump in and start talking about data model and relationships. And at the core of the Salesforce data model is something called the SObject, which is short for Salesforce object. Now, this is table-like as far as how it organizes data and how you access the data programmatically. It's organized into a concept of records and fields. And fields are a lot like columns in a table in a database. Fundamentally, Salesforce objects are extensible, they're queryable, they're updatable, and they are relational to some degree, similarly to relational database tables. Now, SObjects also drive customization. And here, there was a period of time where we would use the terminology of model-driven development. In other words, you build your data model, and then kind of everything else hangs off of that. And that's not completely unfamiliar if you've built software, especially using modern programming frameworks. But in the world of Salesforce, there's a whole lot more that you get when you extend your data model. So I have this example data model here of a broker and a property in a property management type scenario. And I'm actually going to use these as I go on a little bit later and do a couple of demos. In addition to that, these are all based off of the Dreamhouse app demo application that we've developed as Salesforce Developer Evangelism. So if you're familiar with that, these will look familiar. And essentially, I'm a broker and I manage a certain number of properties. If I build that extension to the Salesforce data model, there's a whole lot of things that come along for the ride automatically without having to write a single line of code. So for instance, I automatically get both a desktop and a mobile user interface. There are custom business process features that I can use that don't require any coding at all. Built-in reporting functionality. And then also a user-oriented CRUD-based security model and sharing model. And all of these things are kind of considered the declarative features of the platform. Now, in addition to that, if you're going to do any programmatic customization, we also automatically extend the Apex language. And you can see there down to the bottom right where it says programmatic customization, just above there, you can see if you've written any C-type code before, it looks like I'm instantiating an object. And you can see that the name of that object is identical to the broker object on the left. I didn't have to write any code to make that class exist in the Apex programming language. It's just there as soon as I extend the data model. And similarly, we also automatically extend our APIs. So both SOAP and REST APIs get extended automatically. The example I'm giving here at the bottom is a new endpoint that corresponds to the property object on the left. So all that stuff happens automatically, no effort on my part as a developer. It's just there, ready for me to work with. Now, speaking a bit more about Salesforce objects, there is a standard data model. And this is the thing that you kind of get and comes along for the ride the minute you start up a new Salesforce environment, or what we call a Salesforce org. There are CRM-based objects like lead and opportunity and case. And those come specifically with CRM licenses. There are also some more general platform-based objects like account and contact. And these ones, they exist, they're there. You don't have to do anything to use them. You do have to have the right license for the CRM-based ones, but they are an existing data model, essentially, that you can then go and work with and extend. There are also a bunch of standard fields. And what's interesting about standard fields that you see on the right, things like ID, name, created by, last modified by, these are all kind of standard data model features that you would expect to see in any enterprise software system. We give them to you automatically. Now, obviously, with the standard objects, that's not a surprise. We created those. They're there when you start your Salesforce org. On the other hand, when you extend the data model, like when you build custom objects, you also get these standard fields. And so there's kind of this standard expected behavior that, that you always get with certain fields when you add new objects. Speaking of adding new objects, of course, custom objects are a big part. And I already showed you one example with the broker and the property. And if you dive into the Dreamhouse scenario, there's also a favorite object. And then also, of course, custom fields. And similarly, custom fields can be on custom objects, but they can also be on standard objects. So if you have an account or a contact record that you need some custom data in that record, you extend the object with this custom field. And we do all of that using our own metadata in this multi-tenant environment that's called Salesforce. So that's why we don't call, we're not calling these tables. We don't actually modify the schema of the underlying database of Salesforce when you build a custom entity. There's kind of this layer at the application tier that sits above there. And that's actually what allows us to make modifications to a single instance of Salesforce's data model without impacting the performance or the uptime of other customers that are sharing that same instance, right? There's no locking procedures done in the database. It's all done in the application tier. All right, so we have our custom data model, we have some standard data model, and part of that custom data model is also relationships. So you can see here those three custom objects I just talked about, favorite, property, and broker. they all have relationships that are sort of one-to-n relationships. Now, if we were building this in tables in a relational database, right, what we would do is at design time, we would go and build a constraint in our table. And then at runtime, we would have to write the code that would query those two tables and perform a join. In Force.com and with Salesforce objects, the thing that we build is actually called a relationship field. And it works a lot like a foreign key. However, it is sort of at the same time a constraint and a join. So essentially, you're designing the constraint and the join at the same time. And what that means is that there's a little bit less flexibility at runtime. I can't kind of build an ad hoc join into a query. The relationship already has to be there. So at runtime, I write a relationship query, and we'll take a look at what those look like later and talk about how we can kind of build similar functionality to what we might build in a relational database. But that's the big difference when you start to use SOQL and querying your data, is this relationship query feature and the predefinition of the join in the relationship. And speaking of relationship fields, there are two fundamental relationship field types. And this is actually a really important design time consideration. When I go and decide how to build my data model, and if I'm going to build relationships between two objects, I have these two different types to pick from, either a lookup field or a master detail field. So what's the difference? Well, if we look at these different axes of behavior in relationships, this is really where we kind of see the difference between lookups and master details. So nullability, what's the behavior on delete? What's the record sharing access? And how many of these fields can we put in a given object? So those are the four things we have to consider. So in a lookup field, you can make these not required. So nullability is optional. And because of this, we tend to think of lookup fields as sort of a loosely coupled relationship type. In addition, so going along that lines of loosely coupled, when you delete a parent record, you can pick your delete behavior on the child record. So you can either choose to clear the child record field, block the delete of the parent, or cascade the delete. Now there's an asterisk on that because of the next thing I'm going to talk about, which is record sharing access. Record sharing has to do with can a given user access a given record at a given time. So it's kind of a dynamic security model that's based on the actual individual record itself. And in lookup relationships, if I have access to the parent record, let me back up and rephrase that. The access to parent and child records is completely independent. It's completely decoupled. So I may have access to a parent and not be able to see the related child records, or vice versa. I may have access to the children and not see the related parent records. And because of that, if you think about how a cascade delete might work, that means a parent could be deleted and cascade deletes to children without the user knowing that there are child records in there. And so the reason that asterisk is on there is if you want to use cascade delete with a lookup relationship, you have to contact Salesforce support. They'll explain that to you again. They'll make sure that you understand the implications of that, and then they'll turn it on for you. So finally, as far as maximum allowed fields, you get up to 25 lookup relationship fields in a given object. So there you go. Now, master detail relationships, different, right? So first of all, master detail relationships are always required, right? When I add that field, I must have a parent value in the child record when I create that child record. I can't ever delete that value. And partially because of this, when I've advised people in the past on whether or not to use master detail relationships, one of the things that I have them think about is think of the relationship between sort of order and order line item. And if your data kind of follows those semantics, then master detail is often a really good choice. In addition to that, because of that very tightly coupled nature, we cascade the deletes. The sharing, again, that record level access gets inherited from parent to child, but we only allow you to have 2 of these master detail fields. And part of the reason goes back to that sharing access. When you modify sharing on a parent and it cascades to a child, there's a background process that has to reconcile all of that. And so if we were to allow tons and tons of master detail fields in a given object, we might be forcing Salesforce and our servers to do a ton of work to keep up with that. So we give you some limitations and some pretty strong limitations on how many of those you can have. All right, so let's jump in, and we'll do a quick demo here and kind of step through this relationship of property and broker. And again, I'm using the Dreamhouse sample application. If you're interested, this is actually a managed package that you can easily install into any Salesforce org. It's not a production-ready application, so don't go do it in your production org. Go sign up for a developer edition org and install it and take a look. There's some really cool use cases, and all of those use cases are found on that website, developer.salesforce.com/Dreamhouse. All right, so let me jump over and take a look at my Salesforce org. So this is the Dreamhouse application, and I'm actually looking at a custom page. This isn't a standard page just because it looked pretty. But what I want to do is jump into and look at the broker and the properties data. So if I go here, I have my recent brokers showing up in the Lightning Experience tab. And I'm going to go and take a look at Caroline Kingsley. So Caroline Kingsley, she's my broker. I can see some information about her. She's her name, some contact details, the region that she's in, etc. And I can also, on this tab over here, I can look at related data, and those are the properties. So again, I can just kind of drill into that, and I can see the property detail as well. And that seems like it's taking a moment to come up, which that's interesting. Well, let me just jump back, try one more time. And I don't know why that's not refreshing. But tell you what, we're just going to jump right ahead, and let's take a look at what this looks like on the configuration side. So here, to take a look at the configuration, I can go in here and I can jump into the developer console. Now, there's a nice other little shortcut here, and I can just go straight to editing the object details for the broker object. Sorry, this is a properties object. So I'll do edit object. And you can see that I'm taken directly into setup. And there's the details about this particular object. Now, on the UI, we called it properties or property, and you can see there's this thing called an API name. And the API name is the developer name for any entity or field. All right, so there's my property API name. In addition to that, I see all of the different fields that are part of that. And if I take a look, there's this field here, which is broker. And you can see that that's defined as a lookup relationship. So let's take a look at that. All right, and so here's the information about that lookup relationship. And again, there's our broker name. And what's interesting is that we can see that that is the object that it's related to. So if I want to go and take a look at the broker object, I can just click through there. And that'll take me through, and I can see that broker object. And distinctly, all of these custom objects and fields I've shown so far have this __C name to them. And I'm going to come back to that when I start to talk about relationship queries. All right. So that's it for now, just a little brief overview of that. If you want to see a picture, actually I was going to do that. I'm just going to jump here to the schema builder. And so the schema builder here is a nice visual way of representing that. And that's the screenshot that I showed earlier. So there we can see there's our broker object. We can see it connected to the broker relationship. And so obviously that's going to store an ID value when we get to runtime. All right, so now let's switch back to the slides. Moving on to relationships and SOQL. Now, SOQL stands for Salesforce Object Query Language. It's very SQL-like. So again, if you are a developer who's done any kind of work with databases, you've probably done a little bit of SQL. And so I always tell people that learning SOQL is actually pretty straightforward. The big thing to be aware of is that there are going to be some small differences. So that's a big part of what I want to focus on today. So obviously, this is how we're going to query the Salesforce object layer. And then where do we actually use SOQL? There is Apex. There's also different developer tools that are out there. So I'm going to show the developer console, Eclipse, Workbench, the Salesforce DX CLI as well. And then obviously all of those things I just described are API tools. So essentially, SOQL is a place where you're going to be querying Salesforce using either the API or Apex. And as I said, first it's going to look familiar. There are some important differences. So what I would say is probably the most important thing is to start to learn what those differences are. The other thing is that you don't want to leave behind good data design practices. You still want to design things in a fairly relational way. You don't want to get too denormalized because we're not really dealing with a true relational database with the multi-tenant architecture. But still, think about things from that standpoint, and most of the time you're going to get things right. So here we have our very first SOQL query in the webinar. And you can see it looks really familiar. So select ID name status from property C, where beds is greater than 2. Okay. I'd be really surprised if any developer who's done a little bit of SQL can't look at this and immediately understand what's going on. So like I said, very similar syntax. There's a few other things. First of all, we do have indexes. Now, so for instance, the beds field here in the where clause, we could very easily index that field and thereby making our queries perform a little bit faster in most cases when we go and try and retrieve data. Finally, just a couple of other things. There are transactions in Salesforce, but you don't actually create them. You sort of hook into the existing Salesforce transaction. That part is a little bit different. And there is a trigger-like feature, so very similar to database triggers. The difference is that you're not writing it in SOQL. So just be aware that you can do trigger-like functionality, but you're going to do it a little bit differently than you would in a relational database. And then a few other differences, right? So first of all, one of the things that pops up for most people immediately when they start using SOQL is there is no select star. If you think about it, this is really just us making sure that we don't ever get any full-on selecting of every single field in an object into our production servers. And there's an additional risk that Salesforce has in that every custom object can have up to 800 custom fields. Now that seems like an obscene number of fields, but I know for sure that we have some customers who've gone over 500. So you can imagine that if you were to issue a SOQL query that was select star, and it was a decent number of records, and you had 500 fields in that object, you would probably wait a long time for that query to come back. So that's part of the reason as well, is to ensure that that doesn't take place. A few other things, there's no concept of a view in SOQL. SOQL is read-only, and this is actually kind of a nice thing because it does mitigate some of the injection vulnerability that SQL has. You can still do injection from the standpoint of an exploit against SOQL if you write your code incorrectly that's using SOQL. There are risks that you can take, but fundamentally those risks are much more mitigated. Indexes, as far as what you can index, is quite limited in the Salesforce object model, but some really positive things. So first of all, the object relational mapping is automatic. I don't need to worry about, I've created a new place to store data. Now I need to do some mapping so that I can go use it in code. That's kind of done for you. And finally, for schema changes, if I go and write some Apex code that references something in SOQL or references that in Apex code, you are going to be protected from accidentally changing the name or the data type of your fields or your objects. Few of the things, I know, we're kind of going on in the litany of what's different, but these are the things I want to focus on as well. First of all, SObjects aren't tables, right? That's why we have SOQL in the first place. If you understood the underlying data model, and I'll give you a link to the multi-tenant architecture white paper at the end of the presentation, you would not want to write the SOQL that queries our actual data model. So the SObject data model is kind of a customer presented data model that's much easier to query. And as such, SOQL is really kind of the API for querying that data model is a good way to think about it. Also, relationship metadata, since we kind of have this hybrid of both a join and a referential integrity constraint, the way that we query that is different. So I'm going to spend some time focusing on that syntax now. And then a few things that that we do to protect ourselves again from the concept of multi-tenancy. We explicitly meter how much querying you do. So from the standpoint of API calls, we have a maximum batch limit size for the number of records that can come down per request to our servers. And in Apex, in our code that runs on our platform, we have something called governor limits that limit the number of records you can return in a given transaction as well. So just be aware of those, look them up. They're pretty straightforward. They sort of enforce good programming practice is one way to think about it. Although I'd be lying if I said developers loved all of those limits. All right. Now going back to this idea of our API names and this __C suffix I showed earlier. There's also an __R suffix. So, so what are these all about? So first of all, let's just take this and kind of start from the standpoint if we were thinking about this as like tables in a database. Each of these tables would have something like a primary key, right? And that's the ID field. So in the Salesforce object, the field is always called ID, and that's our primary key, essentially. And if we wanted to build a relationship between broker and property that was 1 to n, then what we'd want to do is we'd want to add a foreign key column in property, okay? And of course, the data type, because we're storing the ID from broker, would be a data type of ID. And in Salesforce, ID is an actual data type when we materialize data at runtime. This is where it kind of gets different because in addition to that, we give you a second virtual field. So broker __C is going to store an ID value, but broker __R is actually a way to materialize a related broker record in property. So it's this virtual actual broker record, depending on which fields that we query. And that doesn't stop there because some of you may be thinking this already. Do we do something similarly on the broker side for property? And we do. So properties __R is essentially a list of related properties in this broker record when we query it correctly. But it all comes down to the query, and that's kind of the key. So how you construct the query will determine whether or not you're going to materialize either of these virtual objects inside your record once you get it in your code. So we'll go through a couple of examples here. First of all, the child to parent. So this would be where I want to do a query of property records, and I want to see data about the related broker of each of those properties. And so you can see in white on the left-hand side, we have this select ID name and broker, right? So that looks pretty standard. And then after broker, there's a comma. And then I've indented these and changed the color just to highlight them. But the indentation is not required. Broker __R.ID, comma, broker __R.region C. So now what's going to happen is SOQL is going to take that. It'll return actual property records, provided the status is available, and it will materialize the actual fields for property as well as a related broker object for each of those properties. Now, I've chosen to represent this in JSON. because I think it's a really good visual representation for developers to understand what's actually going on here. Now, if you request this via the REST API, it will actually return JSON, but this isn't the actual JSON. This is just really more for the demonstration of how this works. And so over here, right, broker C, as I said, right, that's storing an ID value, but broker R, these ones over here, that's actually an actual broker object with those related field values. So that hopefully illustrates what this relationship query is doing. And it's probably worth highlighting here that if there was no related broker record for a given property record, we would still query the property values. So we haven't actually done an intersect query, but I'll show you how to do that in a second. All right, so what about parent to child records? So here we have a broker record, its actual fields, and then comma, and inside after the comma, we actually have a subquery inside of the braces here. And what's interesting about that is that the from isn't property underscore underscore C, but it's that virtual list properties R that exist in the broker object that I just showed you. So if the region is north, go get all the brokers, their fields, and for each broker, a list of related properties. So again, you know, we've accomplished this query the child and the parent, or the parent and the child. And over here in the results set, you can see that the child properties is an array or a list of a bunch of objects of each field that we queried, okay? So that's kind of the basic relationship query structure, and it kind of spins out from there. You can get much more complex. I can actually add a where clause to this subquery. I can do things like intersection, and that's actually the next thing I want to focus on. So here, you know, we're doing very similar to the very first one that we saw. So select ID name, broker R name and email. Notice we didn't query the broker ID field in this case, and so we don't actually get the ID of the related record. It's just something to be aware. It's very explicit. We don't assume you want data just because, you know, unless you actually request it in the case of these queries. And so we're doing from property, and then where broker R region is equal to north. So now we are only going to return properties where the related broker is in the north region in the first place, right? So that actually gets us our intersect query, where now we will only get back properties provided there is a related broker that meets the criteria of this particular search. Okay? Now, I'm going to take one step further into this and talk a little bit about aggregate queries to set up my demo. All right, so I'm not actually doing any relationship queries in this particular example. I'm just doing some aggregations, and this is this isn't that cutting edge. You know, pretty much everybody who knows SQL knows how to do some aggregations, and you can see here that that's all we're doing is that we're grouping by city for the property, and then for each city we're going to do account, max price, and average price, and then we get back our values there. Okay, so that's pretty straightforward. But what that's going to do is set us up so we can go and take a look at the demo I'm going to do. Because what I want to do is show you how to build a query where we find the total property value on the market broken down by each broker region. Okay, so region is an attribute on the broker, but we want to have the property values. Hopefully that makes sense. Let's jump in and take a look at the demo. Okay, now to do this, I'm actually going to go here and use the developer console. And I've got a couple of open tabs here, but let's go ahead and close those. And I'm going to just clear the query editor. So down here, this tab is where we can type in a SOQL query. Notice it also says a SOQL query. SOQL, I'll just mention quickly, is the Salesforce object search language. If you're doing full text searches, this is the way to go. If you are getting very slow searches in SOQL and you're using the like with wildcards, then what you might want to do is fall back and try SOQL, and oftentimes you'll get better performance. Just a little plug for SOQL there. Okay, so I'm going to start with select ID, name, price from property C. And I'm just going to jump right in and do my where status C is equal to available. And let's take a look. So there we go. So basic query, nothing exciting there. Let's take it a bit further. And now what we want to do is, in addition to the property, let's get some related data about the broker. So we'll jump in here and we'll do broker. Oops, except that's a serious typo. So broker R, remember, is going to allow us to query across the relationship to the parent, dot name. And we'll add to that broker R dot region C. And you'll notice that name is one of those standard fields. So no underscore underscore C, region. That is a custom field. And so we get that underscore underscore C. I also want to mention here, I had to extend the data model for Dreamhouse in order to do this region query that I'm going to demo. So that doesn't exist in the Dreamhouse demo, but maybe I should do a pull request after this and see if I can get them to add that in. All right, so I'll go ahead and execute that. And we're good to go. So now what we have, you can see, is that in addition to those initial 3 fields that I returned, I also have my broker R name and my broker R region values showing up, right? Now, what we wanted, though, is we wanted to aggregate information about the price of all properties in a given region, right? So essentially, in a particular region, what is the, what's the total amount of dollar value or euro or pound value on the market right now, okay? So let's reform this query a little bit. I'm actually going to drop off these different attributes here. And the first thing I'm going to do is I'm going to do a group by. And I'm going to say group by broker R dot region C. So let's group by that parent value, okay? We'll keep the status as available, right? So what's currently on the market, it would be available properties. The from isn't going to change, but here's where it gets a little different, right? So in addition to grouping by this, we're going to return that because that now becomes an interesting value to us, right? And actually, I can just do it this way. Here we go. And then I'm going to turn around and let's say, let's do a sum of price C. And that's pretty much it. So let's execute that and see what we get back. So there we go. So for my northern region, I have, what's that, 2,965,000. For south, east, west, again, we have these aggregates. And then the nice thing is that we can kind of, add additional things in as well. So I could do sum, not just the sum, but what's the sum of the price, rather, but what's the sum of the assessed value. And then we can, so maybe what we want to do is see, are there any cases or regions where we're overvaluing or undervaluing our market, let's say. And there we go. So we have our relationship. We're aggregating on that related field. And then we're doing a sum of the actual fields of this local record here, or this local property object. All right. Cool. So let's do a quick recap and then let's move on. I'm sure we have lots and lots of questions. We're doing great for time. So first of all, data model and relationships. Yeah, it looks like relational database. It's actually not relational database. We have this multi-tenant architecture. We have these predefined joins, and then these relationship types we have to think of. And one thing I just want to underscore, those different axes that I talked about, things like the delete behavior, is it required or not? The sharing model and the number of fields. Oftentimes, people think more around kind of the cascade delete, or do I want this to be required or not, as to should this be a master detail relationship? But actually, more often than not, the reason that you can't do a master detail relationship is because of the sharing. If you ever have an instance where you must have independent access of the parent records to the child records, in other words, you need some users who will have a certain access to the parent records and have less access to the children, or vice versa, you have to use a lookup relationship. So it's just a little bit of advice there I want to put out there. And then finally, with relationships in SOQL, right? SOQL has relationships, but we don't write SOQL like relational joins happen inside of SQL. You can't ignore limits. If you want to write SQL that goes down and queries one record, gets it back, and then goes back and queries another record, you can do that. If you try and do that with SOQL, you're going to run into one of those limits that's going to get in your way. And at some point in time, hopefully during testing, you're going to realize that you've written code that is non-performant. And finally, again, stick to good relational database design principles, but check your assumptions a little bit. Don't go too normalized, too denormalized. And remember, you're not actually designing a database schema. You are designing a Salesforce schema. So bear that in mind. A couple of things to explore further. If you're going to deal with very large data volumes, there's some things that can come in really handy. The first is called a query locator. This is sort of an abstraction of database cursors. And there are ways to access this both through the API and through Apex. If you want to understand more about how we take your SOQL and construct it to real SQL, because we do have a real relational database under there, read up about the query optimizer. And then finally, once you've done that, if you're having slow SOQL queries, there's a feature called Query Plan. And this actually allows you to examine your query optimizer behavior and try and understand, how is the optimizer working, and how can I maybe change my query or change the way that I'm getting to data so that I get a better performance in the future. I have a whole bunch of references here for things to read more about. This particular blog post that's listed here is a different one than the one I wrote. Do check that out. They're very much along the same vein. This one goes a little bit deeper into relationship queries, though. The SOQL and SOSL guide, more about sharing, more about limits. And my favorite white paper of all time for Salesforce is the multi-tenant architecture white paper. If you've ever heard me talk more than 10 minutes, and you're new to Salesforce, I've probably mentioned the multi-tenant architecture white paper to you. A few little tips on Trailhead. These are different badges that support the different things I talked about today. I want to mention this one, Database and .NET Basics. If you're not a .NET developer, you should still check this particular badge out. It goes to a lot more than just .NET developer stuff. API Basics is great. Apex Basics and Database will show you like Apex and SOQL. And remember that coming up in June, we have the Trailhead DX Developer Conference. So this is a developer conference. We deliver it as part of the developer relations and Trailhead team. There's 2 days. Everybody in developer relations is going to be there. We're going to have tons of great talks from R&D and from technology and products. So please come to San Francisco and check that out. And with that, I'm going to pass it back to Chris.
Hey, thanks, Peter. And just a quick reminder that if you're interested in joining us at Trailhead DX, you can register now. We have early bird registration now. It's at developer.salesforce.com/trailheadx. Again, developer.salesforce.com/trailheadx, or just Google for trailheadx, and you'll find it. And now with that, as promised, we're going to go ahead and jump into Q&A. And a quick reminder, if any of your questions are not answered as part of this live Q&A, check out the developer forums, developer.salesforce.com/forums. Go ahead and check out Trailhead, trailhead.salesforce.com, or feel free to tweet at us. We are at Salesforce Devs. Thank you. All right, Peter, we have a ton of great questions, man. I'm just going to go ahead and jump right into it, if that's all right with you.
Yeah, that's great. Can't wait.
Cool. So we had a lot of questions about grouping. I think one of the questions was, how do you do a group by in SOQL?
So I'm hoping that those questions came earlier on in the webinar, because I did show an example of group by both in the slides and in the demo. But maybe what I'll do is I'll just do a quick revisit of that, just to underscore that point. So I'll just break out of the slides here and go back into the developer console. So this was the final query that I came up with here, and hopefully you can all see that up at the top. Or it might be easier if you kind of look at it down here. But group by is exactly the same sort of syntactic token as you would use in SQL. It's just group by. And then in this case, I can group by any particular field on the object that I'm querying, or on a related parent object as well. And then I have run into certain instances where group by isn't possible. I don't know what the parameters for that are. I would have to go in and check that out. But then once I group by that particular field, that becomes the only field that I can actually return in my select statement, because essentially that's the summary, right? So you can see in my results set the summary of the different region values up at the top. And then I'm doing the two different aggregations in this case, one sum on a particular field on property, and a sum on a different field, again on property. And there are a number of different aggregate functions available. So I think I showed some in my demo. There's an average one, AVG. You can do mins and maxes. So let's do a max in this case. So what's the highest valued property in a particular region, if that were to be interesting. And there we go. So hopefully that answers the question. I can't think of anything else to say on that, but the fact that it was asked is making me a little bit nervous. Maybe they'll repost into the Q&A to let us know if we got that one right, and then let's move on to the next question.
Great. The next question is, I believe this is a quick one. What do we mean that SOQL is read-only?
Oh, that's a good question, actually. And it's pretty straightforward. There is nothing syntactically in SOQL that allows me to modify data. So for instance, in SQL, I could write an insert statement or an update statement. There is nothing in SOQL that resembles insert or update. Likewise with delete. In fact, SOQL is a pure query language from the standpoint of we modify no data, and we can't even modify the schema. So traditionally SQL does several different things, right? It allows you to do DDL, which is data definition language. In other words, I want new tables, new fields. I want to add an index. I want to create a view, right? Those are all DDL operations. There's DML, which is data modification language. In other words, I want to insert data, update data, delete data. And then finally, there's querying, right, which is the select syntax. Of those three features of SQL, SOQL only has the select syntax. So maybe that makes it a bit more clear syntactically.
Awesome, thanks. Next question is about indexing. We had a lot of questions about indexing. The question is, how do you index in SOQL? And there's a belief that you have to have Salesforce perform the indexes.
That's also a very good question. So there are 2 or 3 things that you can do to custom fields that allow you to index them. And again, I think best to just jump in and show this. So I think let's take an example. Let's see, we have property. I think I mentioned something about what if we wanted our query to perform better on the beds field here? I'm going to go right from the query builder here, the schema builder, and go to view object so we can take a look at how this works. So with certain types of fields, namely number fields, there are certain text fields that support this as well, like email, text, and a few others. you can actually turn on a setting that's called an external ID, or you can also make it unique. So let's go and find beds, for instance, and we'll edit that field. And here we go. So you can see there's a setting here called unique. There's another setting called external ID. If I tick either of those boxes, Salesforce goes and turns on an index on that field. So it's an implicit index based on the functionality that you enable there. And so if I wanted to have an index on this beds field, what I would do is I would just tick external ID. Don't be misled by that word right there. I'm just going to say it. It's a terribly named piece of the configuration user interface. This does not make this field unique. This does if I tick the unique box. So now once I save that, what's going to happen is in the background, Salesforce is going to say, oh, hey, I need to use this as a kind of special value. And external IDs give us some pretty cool features on related data when you are importing or accessing it via the API to write data back to Salesforce. In this instance, though, maybe I don't plan to do that. I just want better performance out of my query. So I'm going to tick that box, and that adds the index implicitly. If you have an idea that you need an index of 2 fields, that's when you need to contact support. And that's the only time, really. Although there have been certain cases that I've heard of with, again, large data volumes. And if you get into one of these scenarios, I've mentioned it once already, where you're dealing with really big data volumes, the chances are you're going to be working closely with somebody on our side anyway, or you already are. But there are some cases, some sort of special cases where Salesforce has turned on indexes or has to manually turn on indexes. And actually, I can even think of one of those. There's a type of field called a formula field. If you know what it is, then you know what I'm talking about. If your formula is deterministic, in other words, if it can't be sort of modified every single time it's retrieved, or if it doesn't have to be modified every single time it's retrieved, then you can actually index your formula field, but you have to contact support to make that happen. So under some instances, yes, you have to contact support, but for just a regular, I have to index this field, turn on external ID, you should be good to go.
Awesome, thanks, Peter. Quick related question. How many fields can be indexed on a custom object?
10.
That's an easy one.
Yeah, and I should also mention there are certain fields that are indexed automatically. So your name field on every object is automatically indexed. And relationship fields, the __C field in a relationship field is also indexed.
Awesome. So we have some questions about relationships.
Mm-hmm.
I'm going to kind of try to lump them into one question. Hopefully I reflect the spirit of the question. Is the __R similar to a foreign key in a relational database? And can account and contact records also have the __R fields?
So to the first one, I would say no. The __R is sort of a virtual field. __C is a real one. And I think probably to illustrate that, I'm going to go back to the slide where I addressed that, which is this one right here. So __C, and I'll just kind of go right through the animation, right? In this particular scenario with broker and property, broker __C, think of that as the foreign key. If you come from a SQL background, if you come from a relational database, think of that as a foreign key. The __R fields, think of those as virtual fields that actually contain an actual record. It's almost better to think about these more in a, don't think about them in a relational database concept, think of them more in an object-oriented context where, this, and that's kind of why I draw it this way, like this is a list of properties, and this is an instance of broker, not this broker C, but that broker C, which is why the color coding there. Hopefully that wasn't too clever, and that's obvious enough. So hopefully that answers the first part of that question. And what was the second part?
The second part was, can you also establish these __r relationships on the standard objects like account and contact?
Yes. So if I wanted a custom relationship between account and contact, I can build that. There are some limitations as to which objects can and can't be take part in certain master detail relationships. But a lookup between two objects is almost always allowed if it's one of the sort of standard data objects that exist in Salesforce.
Awesome. So Peter, we have about 2 minutes and a ton of great questions. Just wanted to check in with you. Do you think we could go a few minutes over as we try to get through some more of these questions?
Yeah, I don't mind going a little bit over.
Okay, great. So everyone on the line, we're going to go till about 11:05 a.m. Pacific time. And with that, so Peter, another follow-up question to the virtual relational objects. Will virtual relational objects be automatically created when you define a relational field in an object?
Yes.
Excellent. Another easy one. So we have a question about master detail nullability. And the question is, can you please just kind of elaborate a little bit further on the nullability criteria for master detail relationships?
They are always non-null. How about that? Yeah, I guess that would be the best way to put it. So again, I did have that slide here, that comparison slide, right? So as far as nullability goes, you can never have a null master detail relationship field. Or a better way to put it that maybe is less geeky, it's always required.
Great. And keeping on with the master detail questions, the question is, and I hope I reflect this correctly, can we change the lookup to master detail relationship once we've created it, and vice versa?
Yes, there's a little bit of a tricky thing to that. Changing master detail to lookup is fairly straightforward, because if you have a master detail relationship, all of the criteria that are allowed for a lookup relationship are already filled, right? But going from lookup to master detail, you can have some of those fields that have been left null. So before you can switch a lookup to a master detail relationship, you do have to go through and do some data manipulation to make sure that every single record with that lookup field has a value in it. And then once it does, you are able to change it to master detail.
Awesome. Here's, I believe, an easy one. Can we use an alias for a field in SOQL?
You can, but so an alias in SQL is most often used and most effective when you are doing sort of joins between two tables. So for instance, if I'm going to select from a single table, alias doesn't really matter. But if I have two tables, it makes the syntax both in my select and in my join much more streamlined, because I don't have to fully reference each table name. So that's kind of the thing that I think about when I think of aliases in SQL. SOQL, however, you aren't writing the actual join syntax, and there's always sort of this what's the word I'm looking for? It's never too wordy. Well, maybe it is, but it's less often that you end up with something really wordy as far as the actual name. So the answer is yes, they exist. I don't find them particularly useful, except in one particular scenario. And I'll show you that because it's actually in, there we go, this slide right here. So this is an example of just a basic aggregate query. And where I've done the aggregation functions, I'm also specifying an alias. And I meant to mention this when I got to this slide, so it must have just slipped my mind. Here is actually, you almost always want to do, I'm going to take the almost out of there. You always want to use an alias in the case of one of these aggregate queries. And the reason for that is that if you don't, what you end up with is just kind of this generic expr0, expr1, expr2. So the actual field names of your aggregations are completely meaningless in the code where you go and use it, which makes it much more difficult to access. So in aggregate queries, on your aggregations, always use always use an alias. In pretty much every other case, I can't think of a great reason to use an alias.
Awesome, thanks. Here's a great question. I think I know the answer, but
I can't wait.
Anyway. Are there any major differences on the back end between Lightning and Classic to consider in terms of data modeling?
That's a really good question. So if I'm going to build something for Lightning Experience versus I'm going to build something for Classic, should I think any differently about data modeling? I would have to say no. It's actually not a question that I've pondered, but Lightning and Classic are essentially the surfacing of your data through the user interface in two different frameworks, essentially. So how you model the data shouldn't really matter in that particular instance.
Awesome. Here's, I think, an easy one. Can we use the in operator in SOQL query editor?
Yes, you can. I would have to play around with it. I use it a lot in Apex. Oops, let's see what I did. Let's escape out of there. There we go. So I use the SOQL query editor in Apex a fair amount. Sorry, let me take that back. I use SOQL in Apex a fair amount. I haven't used the in operator as often in the developer console. So let me see if I can bring that up. There we go. But essentially, I mean, in works just fine. Where where it becomes a little bit more interesting. How much time do you have? We're about out of time. Otherwise, I would show, you can do things in Apex, for instance, where you build an array of values, and then you can pass that array of values to an in SOQL, and that way you can get back the records that match that particular set or range of values. So in exists. I'd have to play around with it in this actual query editor to make it work, but we're about out of time, so I think I'll skip that particular thing.
Awesome. Hey, Peter, thank you so much for the time. It's been a great webinar. Sorry to everyone who's had a question that hasn't been answered yet. If you have questions that you're still wondering about that we haven't gotten to, I'd highly encourage you to check out the developer forums. You can find them at developer.salesforce.com/forums. There's a great community willing to help you out. They'll help you answer those questions. And again, thanks, Peter. Awesome webinar. That's the conclusion of today's webinar. Thanks, everyone, for joining us. And we hope you have a great rest of your day. Thanks, Peter.
Yeah, thanks, everyone.
All right, bye-bye.